Hey, so in this class we're going to go over the power and constant rules. So one thing you have to know is that both of these were developed as shortcuts because the limit definition of a derivative always takes way too much time and is inefficient. So instead of, for example, taking this function, instead of finding this using the limit definition of a derivative, which would take us at least 2 minutes, I can already tell you that the answer to this is 2x using the power rule, because this is super easy and it literally takes 1 second. So yeah, basically just as a shortcut, but if you always want to do it with the limit definition of a derivative, you can, but I would not recommend that because it is super inefficient. But yeah, so for example, for the power rule, let's say I had f of x is equal to x to the power of 3. So the way this works is super easy. You have to memorize one thing, but when you do it a lot, it's not going to be memorizing. It's going to be like breathing. It's going to be super easy. But you have to bring this down and decrease the exponent by 1. So that means is if you have, I'm going to write it again here actually, but if you have f of x, which is equal to x to the power of n, and n has to be a constant. If you have like x to the power of x, this does not work. N has to be a constant. It has to be a number, and a number that is not equal to 0 as well. But so, and then if you have this, it's super easy. All you have to do is bring the n down, and then the exponent on the x decreases by 1. So let me repeat that again. When you bring the n down, what that means is that you multiply by n, and then the exponent on the x decreases by 1. So for example, let's actually do this. If you had, for example, f of x is equal to x to the power of 3, like we have over here, the way this works is you bring the n down, so you multiply by 3, and then the exponent on the x decreases by 1. So 3 minus 1 is 2. And that is the derivative of this function. So super easy. And if you've watched my last limit derivative video, which I recommend if you want to learn that, you would have seen that to do this, it would take at least 5 minutes, and it would not be this easy at all. But yeah, so once again, the power rule is meant as a shortcut, so we just found this in basically 2 seconds. The constant rule is even easier. This is the easiest rule you've ever seen in your life. But if you had f of x is equal to a constant, so like any number, once again, it cannot have x in it, but any number at all, the derivative is equal to 0. That's it. Those are the 2 rules, and we are done both. Once again, these are both shortcuts. Instead of going through the limit derivative and doing like 5 minutes worth of work to find the answer is 0 at the end. That's not good. So yeah, if you know these 2 rules, you can basically solve half the derivatives out there. So yeah, let's get into more examples. Okay, so for the first question, here we have, it says d over dx of x cubed. So one thing that you need to know is that d over dx is another way of saying the derivative of this with respect to x. So for example, in another question, if you had d over dx, so the derivative with respect to x of y, this is 0. Because in this case, y is considered a constant because it's not an x. We only derive values that have an x in them. So if it doesn't have an x, it's considered a constant, even though it might be a variable in front of you. But once again, since it's not an x, it's a constant to us. But yeah, so that's that. But in this case, the way of doing this is once again just find the derivative of what's inside. It's very rare that you'd see another variable like y, because usually you don't want to get confused by that, and teachers won't usually confuse you by doing that. But once you get into more advanced derivatives, you might see that. But at that point, this would be super easy to you, and you won't even have to think about it. But yeah, so for now, what this means is that you have to just find the derivative of whatever is next to it. So the derivative of this, once again, like we learned, this is going to be the power rule, but you're going to bring the 3 down. So 3 times x, and then x is going to have a power of 2, because we decrease the power by 1. So once again, the 3 goes down, and then the exponent on the x becomes a 2 because it decreases by 1. That's it. We are done. Okay, next question. Let's do the exact same thing. So the 6 goes down, bring the 6 down, and then the exponent on the x decreases by 1. So 6 times x to the power of 5. For the next one, this one is a tiny bit more difficult, but it's the exact same thing. So the way you do this is first you have to bring the constant out. So this would be 2 times d over dx of x to the power of 4, and then this is equal to 2 times x to the power of 4. The derivative of that is 4 x cubed, because once again, bring down the 4, then the exponent on the x decreases by 1, so that's it. And then after that, you multiply these out, so 2 times 4x cubed is 8x cubed, and you are done. You could have actually noticed that we didn't even have to bring the 2 outside. If you did this from the beginning, I'm gonna write it over here, but if you bring down the 4 times 2 is 8, and then the exponent on the x decreases by 1, so x cubed. So you don't even have to bring the 2 outside, but this is kind of the formal way of doing it. But in reality, you don't even have to do it. You can just get to this answer just by looking at it, basically. But yeah, so that's question number 3. Question number 4, same thing. So I'll do it both ways again, formally and informally. So first, bring the 4 outside, because multiplying by constant doesn't really matter for derivatives. And then this would be equal to 4 times 3x squared. The derivative of x cubed is 3x squared, and then 4 times 3x squared is 12x squared. Once again, informally, even easier. So 3 times 4 is 12, because you bring the 3 down, so 3 times 4 is 12, and then the exponent on the x becomes a 2. That's it, we're done. These are always going to be the same, but yeah, obviously you can probably tell that this is a lot easier, and it's kind of almost like a natural thing to do, so you can do that if you want. But yeah, next question. Let's only do the faster way now. So we'll bring the 5 down. So 7 times 5 is 35. And then x has an exponent less than 5, so 4. So x to the power 4. That's it, we're done. Over here, when you have two things added up, this is called the addition rule or something else. But yeah, this is very easy. It might seem hard, but this becomes the derivative with respect to x of 6x squared, and then plus the derivative with respect to x of 3x cubed. Basically, all I did was, if you want to find the derivative of the entire thing, you have to find the derivative of each part alone. That's it. So this would be equal to the derivative of 6x squared, bring the 2 down, so 12, and then x squared. If you decrease the exponent by 1, it becomes x, so that's that. And then plus 3 times 3 is 9, and then decrease the exponent by 1, you have x squared. That's it, we're done. Once again, all that happened was you basically found the derivative of each of these separately. This only works for addition and subtraction, but it does not work for multiplication and addition. I'm going to do a video after this about the product and quotient rules, so that's when you actually have two things multiplied. But yeah, it would not be this. This only works for addition and subtraction. If you have two things added or even three things added, you can do this because it's the same thing. But yeah, so for this one, let's do it again. So this would be the derivative with respect to x of negative 2x to the power of 2 plus the derivative with respect to x of 5. So this is super easy, but for this, the 2 gets multiplied and goes down. So negative 2 times 2 is negative 4. And then the exponent on the x decreases by 1. So you have x to the power of 1. And that's it. So just x. And then for this, the derivative of any constant is 0. So we can just say plus 0, which is basically the same as negative 4x. So that's it. We are done. But yeah, a quick recap before we move on. Two things here. So the derivative of this part is negative 4x, and then derivative of any constant is 0. So you also might notice that any constant that you have basically goes away. And there's this trick that you actually might see at school. You might get a question of what's the derivative of dx of pi squared. So you might think, okay, this is actually going to be 2 pi to the power of 1. This is wrong. Pi is a number. It's also a constant. This is actually going to be equal to 0. This is the correct answer, because once again, pi squared is a constant. Just because you have an exponent doesn't mean it's a variable. Teachers do that to confuse you, so be careful with this. It's a very common question. But once again, if this is a constant, the answer is 0. That's it. That's all you need to know. Okay, question number 8. Over here, let's once again split them up. So first we have the derivative with respect to x of negative 4x cubed, and then plus, or even minus, but let's just do plus. So plus the derivative with respect to x of negative 2x to the power of 4, plus the derivative with respect to x of x cubed. So once again, this is pretty easy. Let's actually do it. So bring the 3 down here. So negative 4 times 3 is negative 12. And then the exponent on the x decreases by 1, so you have x squared. For this one, multiply 4 times negative 2. So 4 times negative 2 is negative 8. And then the exponent on the x, once again, decreases by 1. So you have x to the power of 3. And for the last one, we have, this is a 3. Let me just rewrite it. But, so bring the 3 down. So 3 times 1 is 3. And then the exponent on the x decreases by 1. So you have x to the power of 2. And yeah, so something else that I probably did not say yet, but when you bring this down, you always multiply by 1 because this is always 1x cubed. So I'll write it down here, but x cubed is 1x cubed. So when you bring it down, you're basically multiplying by 1. But yeah, so that's a very quick thing that you probably already noticed because it's super easy. But yeah, question number 9, this is pretty easy as well. So let's split this up again. Derivative with respect to x of 2x to the power of 7 plus derivative with respect to x of 3x to the power of negative 4 plus derivative with respect to x of negative 6x to the power of negative 2. So that's it. And now let's find each one of them. For the first one, 7 times 2, that's 14. X exponent decreases by 1, so you have x to the power of 6 because we had a 7. After that, let's do the next one. So you have negative 4 times 3. But yeah, if you have a negative exponent, the entire exponent gets multiplied when you go down. Not just a 4, but negative 4. So negative 4 times 3 is negative 12. And then the exponent on the x decreases by 1, but minus 4, I'm going to write it down here, minus 4 minus 1 is actually minus 5. So it's not going to be negative 3, it's going to be negative 5. Once again, all the rules apply for division. Do not overthink it. Do it as you know. So just because you saw a negative sign doesn't mean that the rules get dropped. They are the exact same rules. So yeah, don't panic basically. But yeah, so that's that. And then for the last one, let's do the exact same thing. So over here, negative 2 gets multiplied by negative 6. Negative 2 times negative 6 is actually 12, and positive 12, not negative, because you have two negatives, which make it positive. So yeah, negative 6 times negative 2 is 12. And then the exponent on the x decreases by 1. So minus 2 minus 1 is minus 3. So times x to the power of negative 3. This should be your answer. Once again, all I did was I basically found the derivative of each one separately and added them together. And once you actually use this a lot, your brain won't even need this to work it out. Like, I can just look at this and find the derivative of each one separately. But yeah, that's that. Question number 10, last question. Before we start, I'll do this two ways, the way that people would usually do first, and then I'll show you an even better way. But yeah, so first way, the most common way, is that you would once again split it off. So derivative squared of d squared x. And by the way, what the squared means is that you're going to find the derivative twice. So it's kind of like saying the derivative of the derivative. You just have to do it twice in a row after finding the answer. But yeah, so derivative squared of d squared x times, I'm going to do some purple, yeah, times 2x to the power of negative 4, and then minus derivative squared of d squared x of negative 6x to the power of negative 3. I just made this a positive, by the way, because that was a typo. And then next, so plus d squared over d squared x times x to the power of negative 4. So let's actually find that. First, let's find the single derivative. We're going to do this in 2 steps. But yeah, so this would first be the first derivative of this. If you only do it once, if you only do one derivative, negative 4 times 2 is negative 8. And then x decreases the exponent by 1. So minus 4 minus 1 is negative 5. So far we have this. But we only found one derivative. So what we can write down now is, instead of writing this, let's move it a bit to the side. And then we still have 1d over dx. Because once again, let's look back at this. First, we had 2 of them. We only got rid of 1. So we still have one more loop to go through. But yeah, so far right now, we can write this for now. And then next up, let's do the exact same thing. So plus d over dx, because we're only going to do it once again. And then negative 3 times negative 6 is 18. So I'm going to write 18 over here. And then the exponent of x decreases by 1 again. So negative 3 minus 1 is negative 4. And the next question, so and then plus d over dx once again, x to the power of negative 4, bring the negative 4 down. So you have a negative 4 over here, and then the exponent on the x decreases by 1. So negative 4 minus 1 is -5. And we are done the first step. Next step is going to be basically the same as we are used to once again, this entire thing in brackets. But yeah, so -8 times -5 is 40. So you have 40, and then x to the power of -5. If you decrease the exponent by 1, you have x to the power of -6, because -5 minus 1 is -6. And then plus -4 times 18, this will be 40 plus 32, so 72, and a negative sign, so -72. But in other words, if you have a -72, this positive goes away. So we have minus 72, and then the -4 decreases by 1, so you would have x to the power of -5. Okay, once again, we're just doing this one step at a time. If I'm going too fast, feel free to pause the video. And then next one, so -5, bring down to the -4. I'm going to do it in purple, but yeah, -5, bring down to -4. Multiply them together, you get 20. So -4 times -5 is 20, so plus 20. And then decrease the exponent on the x by 1. So since it's -5 right now, it becomes a -6. And we are done. But one thing you can notice is that we could have actually combined both of these together to begin with, because they both have the same exponent. So let's actually combine these. If you have 40 of these plus 20 of these, you have 60 in total. So 60x to the -6, and then minus 72x to the -5. One more thing. Okay, so you might ask, why do we combine them now if we could have combined at the beginning? That was the mistake I kind of talked about. It's not really a mistake, but if you already noticed that you can combine these together, it would make stuff a lot easier. So we would not have had this one more term all the time. We would have only had 2 terms instead of 3. But yeah, so kind of look at the question before you start, because there might be something that makes the question a lot easier, like a quick simplification or a quick addition. So yeah, just look at the question before you start, but no matter what you do, you should get the same answer. So we are done once again.